y-intercept. Okay, so the y-intercept is important, right? So what's the y-intercept up here? Say that one more time for me. 81 divided by 16. Anybody want to push back on or add on to 81 divided by 16? Jalen, do you agree? Okay, why? You just agreeing because you want me to stop asking questions? Y'all, we do stuff like that, we're going to struggle in my class. Like, we got to engage in this conversation. We got to pay attention. Like, I cannot help you if you're not trying. So I'm going to come back to you in a second. Eliza, do you know why? Do you agree or disagree with 81 divided by 16?
I don't know.
You don't know? Jose?
I agree.
Why do you agree?
Because it's 0.
Can anyone add on to the 0?
Like this, the y-intercept.
But how do you know?
Because that's what you said. If it's 0.
You say it. If what is 0?
Like in the x, if that's 0,
If the x is 0, then you're looking at the what?
the y-intercept.
So Jalen, why is 81 divided by 16 the y-intercept? How do we know it? Good morning, Rakai. Did you listen to Jose's explanation? So what did he say? Jose, can you re-explain it so that Jalen understands?
If
Thank you.
if x is 0, then there's your y-intercept.
So Jalen, why is that my y-intercept? Okay. Z, why is this my x and my y-intercept? Is the x is 0? David, why is this my y-intercept? Because the x is 0. Guys, if we are disinterested, like I can't help you. If we're not even trying to learn when other people are explaining things, I cannot help you. You are capable of growing and learning, but if you're not engaging, you're not going to grow and learn. You've got to know this. That y-intercept shows up time and time and time again. So how do we know when we're looking at a y-intercept? Because the x is 0 every single time. That's my y-intercept. With linear and exponential functions, it's important to know the y-intercept because that's a good starting point. But I will say this, that's not where I started. Marshall, how did you get started on this problem? I said Marshall, I'm going to say Ethan. But Marshall, how did you get started on this problem?
Is it still up here?
No, I collected it, but the table's right here on the board.
I looked at the 0 in the X slot,
Okay.
looked at the Y, and got a Y-intercept.
Okay. Did anybody start anywhere other than the y-intercept? Billy Kate?
I just divided 16, or 12 by 16.
Okay, well, why?
Because I knew that was how I could figure out what it's multiplying by.
So you're trying to look at the what? You're hinting at a really important idea. What is Lily Kate referring to that she's trying to find when she does 12 divided by 16? Jacoby? The constant factor, which is the what? There's a rate of change, right? So Trayana, what's the first thing we're supposed to be actually looking for? We need to look at the what?
The lines.
What did Lily Kate just say? She looked at.
She divided.
She divided to look at the what? Can anyone help Trayana out? I'm going to come back to her. Say it one more time. The rate of change. Trayana, what was she looking at? The rate of change, right? Jamarcus, what was she looking at? Good morning, Sinai.
Rate of change.
The rate of change. Guys, what defines each type of function? The rate of change. I cannot emphasize this enough. If you want a linear function, what rate of change are we looking at? Linear function has what rate of change? Not just repeated addition. So hear me clearly on this. I started scoring the understanding checks this weekend. I did not finish. I apologize. There's a lot. But it is not just repeated addition. Because what other type of function has an additive rate of change other than linear? What type of function other than linear has an additive rate of change? Say again. Quadratic. So we need to tell the difference between repeated, like which types of additive rates of change, right? So not just repeated addition, what type of repeated addition? Constant additive rates of change, or defining that linear function. Yes, ma'am. Good morning. Yeah, come on in. Guys, we've got to remember, if we're talking about a linear function, I cannot emphasize it enough that you have to think about that constant additive rate of change. That's it, right? If we're talking about an exponential function, what are we talking about? What rate of change? Constant multiplicative, which Jacoby named it earlier. It's called a constant factor. What's it called, Jim? Constant factors, right? We've got to recognize that each function is defined by a rate of change, right? And so, Lily Kate, I do want to ask this: how did you know to do 12 divided by 16? Like, I'm going to come back to some other details in a second, but how did you know to do that 12 divided by 16?
I just started with the first two points, and I knew that if that was the first one, then it would go by that amount each time.
So,
But I made sure to check it to make sure that
That it-
was it. So it
that it was
didn't go
constant
back.
factor. Why didn't you do addition or subtraction, though?
I mean, I didn't do addition because I know that 12 is less than 16, so it couldn't be adding up.
Okay. So why not subtracting?
Because
Because remember, subtracting is a type of addition.
Negative.
It's adding a negative, right?
Because that's all the fractions.
Okay. That's a quick little hint, right? If we're going from whole numbers to fractions, can we be subtracting all the way through?
No.
Notice minus 4, 12 to 9 is minus 3, so is that constant additive? Jalen, is that constant additive? Is that adding the same amount each time? No. So could it be linear? Guys, we've got to go back to the foundations. We've got to look at those rates of change. And so we're talking about constant factors. And Lily Kate is hitting on the quickest way to identify a constant factor. If I take 12 and I divide it by 16, pick up the calculator, what is 12 divided by 16? I'm not expecting us to always know this off the top of our head. We got to learn how to do exponential functions, not just do calculations. 12 divided by 16 is 3/4, right? And so 16 times 3/4 is 12. And Lily Kate made the note, like I can't just look at that one, I've got to look at the rest. What is 12 times 3/4?
No.
Check it. Pick up your calculators, right? We've got to engage and do something. I cannot help you learn if we're not engaging. Jalen, please pick up the calculator. Do 12 times 3/4. Traylon, did you pick up the calculator and do 12 times 3/4? Thank you. What do we get? 9. What's 9 times 3/4? 27/4. Is that what the next value was? Okay. Remember, guys, we do want the y-intercept. The y-intercept's the easiest thing to identify, but the rate of change defines the type of function. Okay? The rate of change defines that type of function. So, from there, what can we do? Like, this is what I heavily emphasized yesterday, or not yesterday, Friday after the understanding check. Once we know the rate of change, what should we do? Write the formula. We know we're constantly multiplying. Right? So, Rakai, what kind of function are we looking at if we're constantly multiplying by the same value? Rakai, do you agree with Sanaya on the being exponential?
I'm sorry.
You're good. Exponential. So, Phoebe, what's that equation for an exponential function?
Y equals.
Let me pause and remind you, because here's the thing, guys, we got to remember this. We can memorize the equation, and it's not bad to memorize the equation, but the exponential equation is literally built to make sense, okay? What I mean by that is, what is repeatedly happening in an exponential function? Hayden, what's repeatedly happening in an exponential function? Multiplication, right? So Phoebe, how do we show repeated multiplication in an equation? An exponent. Specifically, what kind of exponent? An x. Because remember, we have exponents of 2 now for that quadratic, but we have an exponent of x So we need something raised to the x, right?
So, A times B.
There we go. Raised to the x. Right? Go back to the foundations, guys. These equations are not random. They're not scary. They are built out of what does the math mean. In exponential, I'm repeatedly multiplying, so I start out with a y-intercept and I repeatedly multiply by b, and I have that variable exponent because it's repeated multiplication. Once you have the equation written out, it should be a little bit easier, right? Who was it who identified the y-intercept originally? Was that Jose? Did you do that earlier? Jose, so where's that y-intercept going to go? That 81 divided by 16.
Right there.
I need more precise language. Right where?
8.
A. Oh yeah, A's only there one time. That's a starting value. Remember that variable exponent tells me I'm repeatedly multiplying. So Eliza, what's going to be in the place of that b?
3/4.
3/4? Do you know why? You don't look confident. Can anyone help explain to Eliza why and the rest of the class so that we can learn from this?
The rate of change.
Okay, I need a little bit more than just the rate of change. What about that rate of change? It is,
Multiply.
it's constant. I heard someone say it, I think.
Multiply.
He's constantly multiplying, right? And Marshall, how do we show repeated multiplication? With n? I said Marshall again. Ethan! I'm so sorry. I know. I said Marshall like looking straight at you. Okay, so that variable exponent showing me our repeated multiplication. Right? It's not just the rate of change, it's the fact that we're repeatedly multiplying. So that constant multiplication goes there. Guys, we've done an understanding check on this. I'm going to give you your understanding check back hopefully tomorrow, finish grading and everything and getting feedback on it. But we're going to have to continue doing these bell ringers. This is where I'm going to help you practice these skills. But I'm letting you know right here, right now, is on an understanding check. It will also be on your test. You have to know how to write the equation of an exponential function. You have to know how to write the equation of a linear function. Those are our Algebra 1 skills. We've got to know how to do that. And I'm trying to help build you up in this Algebra 2 class on that, but we got to get there. Yes, ma'am, Lily Kate.
When's our next actual test?
It's an excellent question. Well, first off, we haven't had a full test yet. We've had several understanding checks along the way. It depends on how quickly we move this week. My goal is to have our final understanding check on Friday this week, which would put our test Tuesday, Wednesday of next week. But it just depends. I'm not going to rush y'all just to rush y'all. I want to make sure we develop strong understanding of things. But we're going to have to move more quickly. Cam, do you have your book with you today? Guys, we need our Volume 1 textbook out. Don't forget that. All right. That was definitely longer than I meant to. I apologize. Okay, so I'm always trying to grow as a teacher, as I always ask y'all to grow as students. So I do want to quickly talk about some concerns that I've heard recently, because I need you to understand everything I do, I'm trying to do for your good, and I need you to engage and to trust me. And so I'm going to address some of those things so that we can talk about it, which is always fun when administrator's in the room talking about the concerns, but I think it's important that we have this discussion. We're going to get back to the textbook on equivalent representations. That's where we were in the book, that Module 1, Topic 1, Lesson 3, with the card sort. And then we should have our iPads today because we're going to get to Desmos. Anybody not have their iPad with them?
I got it. It did. Yeah, mine did.
Sent y'all emails. I sent out a message to your parents yesterday.
Okay,
Okay, check our emails.
Mine's
Okay. Do you have a charger with you? Plug it in now. Somewhere around the room, maybe here against the wall, but we need that iPad charging. All right. So here's something I want to start with, right? I do want to apologize. Like plainly put, I'm a human. I get frustrated. I think that's a fair thing to say. So I want to say this. It's not like I've ever yelled at anybody or said inappropriate words or anything like that, but I think that we do see me get frustrated sometimes. And so I do apologize for that. I am human. Please hear me clearly on this. I get frustrated because I know how capable you are. That's why every day when you walk in, I greet you by name and I ask you to respond with, I am capable. But if we're not engaged, if we're disinterested, then you're not going to grow into learning. If we're not doing the things that I need you to do, if you're not putting in that time and effort, you're not going to grow and learn. And so hear me clearly on this. My frustration is never from students not understanding. Legitimate. It may seem like that at times, but my frustration is not over students not understanding. My frustration is over when students don't follow directions. I actually got very frustrated with a student Friday in my third block, and I apologized to him afterwards. I'm going to apologize to the class because I shouldn't have gotten that frustrated. But, plainly put, he did not listen to the instructions. And then when he finished this card sort, he was like, I did it. And I look at him and I go, how did you sort these? What were you thinking about? He was like, well, these are all graphs and these are all tables. And I'm like, that wasn't the directions at all, guy. My guy, like, what? And so we had a discussion about it. And I was like, what does it mean for a relation to be equivalent? He could not tell me. And I was like, dude, I spent a solid 2-3 minutes making sure we understood this. It's not that he didn't understand. He didn't even ask questions. He didn't pay attention. And so if you don't follow directions, you're not going to grow and learn. I get frustrated over students not engaging. If you're not engaging, talking about the math, you cannot grow and learn. Plainly put, right? I cannot be the one to call on you, right? Jamarcus, I love you, but like most of the time to get you talking, so I have to call on you, right? But if you want to grow and learn, and Jamarcus is just one example, and I'm calling you because I know that you're not going to get upset about it, right? If I call on Jamarcus, or if I don't call on Jamarcus, he's not going to be fully engaged. And if you're not engaging your brain, you're not going to grow and learn. I need you to engage, right? And then just not taking the time to think. I don't think that's as much of an issue in here unless we're just not engaging, but I do have some students who just shout answers. It sucks when we get an answer wrong, right? But if we just shout an answer without slowing down to think, yeah, we're going to miss stuff. So I need us engaging in that regard. Okay, so I'm just going to open it up. And this is a legitimate question. Is my class stressful for you?
Yes.
Yes.
Okay, why is it?
Going into depth about everything.
Say that again.
Going into depth about
Yep.
everything.
Going into depth about
Like
everything.
last year, we're gonna have to explain why and everything.
Yeah. I was wondering if that's the case. Is there another reason why it's stressful for us other than having to explain why?
You can move it a different way.
I explained it a different way.
You can move too fast.
I moved too fast? Okay. Let me ask you a question. Because I'm trying to think about the past. When I move too fast, do you raise your hand and say, hey, Mr. Kinney, can you slow down and re-explain it?
Not to stop.
Okay. I can't help you. I can't read your mind. You don't want me reading your mind, right? Give me a heads up. Like, I'm not trying to move too fast. I do have a certain amount of math I have to teach. Okay? And so if I'm moving too fast, I need you to tell me. But at the same time, I will say, I also need us to engage a little bit more and try to pick it up a little bit more because I do have certain math I have to teach. Because if I don't teach you the foundations of Algebra 2, then if you try to take this math or future math like a pre-calculus or anything in college, then you're going to be out of luck. You're going to be struggling. So I have to get to certain ideas. Okay? And I get that. But we got to learn how to think as well. Okay? So let me know that. In terms of like, going in deep and explaining things, guys, if you can't explain something, you don't fully understand it. Like, legitimately. If you can't fully explain it, can't articulate, can't make an argument, then you don't fully understand it. And so what I'm trying to do is help you build the foundations so that you truly understand what's happening. But we have to take solid notes and things like that to have something to refer back to. I want you to be successful. I want you to realize how capable you are. But when I ask you to explain, I know that's stressful. I get that. That's something we need to build up a little bit better. But I need y'all to grow and to learn. And if you don't build strong foundations, it will cause you to struggle later. If you don't understand that precise language, if you don't understand the difference between repeated addition versus constant additive rates of change and linear additive rates of change, when we explore higher degree functions, you're going to be lost. And so I go into detail on things, right? And that's one of the things you were saying tonight, that I go into a lot of detail on concepts.
Explain it a different way.
A different way. Yeah. And that's because I'm trying to be very precise with my language and very precise, because imprecise understandings of things, right, it is what causes some of that disconnect later on when we don't fully understand. And so let me know if I need to re-explain things, right? Don't disengage. Let me know if I need to re-explain things, but I'm trying to help you get strength to build. Okay. And so that's actually the next thing, right? So learning in the past versus my class. So here's the thing. A strength for me. So a weakness, let me address that, right? Weakness is I don't just explain things like in a super casual way. I don't want you to say 3/4. I want you to recognize it's 3/4 or 3 divided by 4. And that's uncomfortable, and so that is a weakness. I need to bridge that gap better. But the strength for me in that is I'm trying to help you build true understanding of that math. The stronger your accurate and precise understanding of that math is, yes? Hello?
I think you hear stuff.
I think I heard it, but.
What did you hear? She's on her way. Okay? So, please understand, precise understanding of that math is important to being able to successfully learn later. And that's where a strength of mine is, that when you learn precisely, you're going to be able to bridge that gap accurately in the future. So please trust me, and please think about that. Are you doing everything you need to do long term, right? If I'm moving too quickly, let me know that I'm moving too quickly so that I can slow it down. If you don't understand something, ask those questions. Also, I have 4 tutoring sessions a week, right? I post the videos to YouTube. I'm more than happy to sit down and talk with you. So I'm going to try to adjust. That's why I'm talking through these things. But at the same time, are you also doing the things that you need to do to be successful? I'm trying to give you those resources. Please make sure you're taking advantage of it. And trust me, engage. If you're disengaged, I can't help you a lot. I've talked a lot, so let's get back to actual learning so that we can engage. And I will say this. A weakness of mine, a student mentioned this on Friday. For me, I don't make every single day the most fun thing ever, right? I try to use the boards as much as possible because I think that overall it's more fun and more engaging to be standing at the boards and doing stuff. But we're not playing games every single day, and I need y'all to hear me clearly on this. Learning is not just a game, it is work. There's rigor to it, and so we need to get better at learning rigorously and be able to explain our ideas. But also when you engage, when you learn something, it feels good to learn something. It feels good to master something. So please make sure that you're engaging to that mastery. So here we are in lesson 3 in the book, M1-33. Right? M1-33. Here's a foundational thing that we have got to recognize. Actually, I'm going to go ahead and go. M1-32 is where you should be. That's not that page. Really quickly. Objective number 1. Can someone read it for us? Lily Kate.
I can identify functions versus relations.
You can identify functions versus relations. We have already addressed this, and you have got to know this difference to be able to be successful in certain things. So what is a relation? What do we mean by a relation? Okay, it is any mapping between a set of inputs and a set of outputs. How can we represent a mapping of inputs to outputs? Tables. How else? Graphs. Equations. Words. Verbal representations. Pictorial representations. Algebraic is the equations, right? We can represent that mapping of inputs to outputs with any mathematical representation. That's the point. So what is special about a function versus that relation? There we go, right? One input maps to one output. -4. What's the only output for -4? 16. What's the only output for -1? If there was another output for -1, it would no longer be a function. We've got to recognize that difference. Now, do remember, a function is just a special type of relation. A relation is any mapping of inputs to outputs. That function is a special case. We're trying to identify linear, exponential, and quadratic functions in each representation. That's something important to pay attention to. But number 3 is the biggest one here. We're going to kind of touch on number 4. Number 3, can someone read that for us? Go for it, Eliza.
I can identify equivalent forms of functions.
Equivalent forms of functions. Talking about graphs, equations, things like that. What does that mean to have an equivalent form of a function? And if you don't know this already, you should look on number 1 and write this down on number 1 on page M1-33. What does it mean to be equivalent? The same what? So remember, in general, equivalent means they are the same, but they look different. So what does it mean to be an equivalent function? What has to be the same?
The output of it.
Just the outputs?
The
Inputs
answer.
and outputs?
The rate of change does, say again.
Inputs and outputs?
The inputs and outputs, right? Could I have these same outputs with different inputs? Yes, 100%. But for it to be an equivalent function, the same inputs have to map to the same outputs. You need to make sure you know that. If you did not already recognize that, and that's something I need to clarify in the future, under number 1, I would make sure I write down equivalent functions have the same inputs mapping to the same outputs. Equivalent, and I really should say relations, right? Equivalent relations have the same inputs mapping to the same outputs. Same inputs mapping to the same outputs. Yes, sir. Say it loud. This is what we started on. If you go to the end of that lesson on page, is it like 43, I think? It's 41, 43, and 45. There's some cards there. We cut those out. Just tear them out of your book so that you can look through them as we're talking, okay?
Can you repeat that one more time?
Say again?
Can you repeat that one more time?
The same inputs map to the same outputs, right? Equivalent relations are when the same inputs map to the same outputs. So a point on a table should be a point on the graph. A point on the table should make the equation what? Anyone know? Ooh, so we need to talk about this. If I put -2 in for x and 9 in for y, what will this equation become? Anyone know? Okay, let's do this. What's going to take the place of y? For -2, 9, what's going to take the place of y? 9 equals 81 divided by 16. When I put this in the calculator, just put parentheses around this and put that division symbol, times 3/4, again parentheses, what's going to take the place of x? What is it? I need everybody to pick up a calculator. I need you to type that equation in and tell me what it says in the calculator. This is a thing that we need to be able to do to make today successful.
Fraction in.
So, and this is one of the reasons why I want y'all to think about that fraction bar. What does that fraction bar mean? Division, right? So I would literally just type in 81 divided by 16. It says what? 81. You missed the 8.
Oh.
So I got one person who said it says true. Huh? False. Check again to make sure you typed in the right way. We need a calculator page.
Yeah, I'm kidding.
You didn't put -2.
Calculator if it's true or false.
So hit enter. Make that a -2.
I'll say false.
Check to make sure you typed everything in correctly.
First not.
Yep. Check to make sure we typed everything in correctly. So, yep, so go up, hit enter. And so this is what I was saying, you want parentheses around this. And you put a 2 instead of a -2. So I'm going to put parentheses raised to the -2. Okay? So guys, make sure you're typing the equation in correctly. Make sure you start with the 9 equals. Right? So 9 equals,
Let me see your receipt.
okay? Put that 81 divided by 16 inside of parentheses. Then times the 3/4 in parentheses raised to the -2. So, you're close, but you see how that didn't work out quite right? That doesn't look like what's on the board, does it? Brown? So, first off, we want the 9 and the equals, and then you need to put parentheses around the different pieces. So 81 divided by 16, parentheses, 3 divided by 4. Not 14.
Yeah.
4, go to the right, raise that to the -2. Then check it, make sure that looks right. Huh? You don't need a square, you need an exponent of -2. So remember, this caret right there allows you to do any exponent. So, when we type our equation in correctly, what do we get? You need to put parentheses around things. Parentheses around the 81 divided by 16, because those go together. Parentheses around the 3 divided by 4. Guys, parentheses are grouping symbols. Make sure you use those. So what do we get when we put 9 and -2 in? Yes, true. So what should I get if I put -4 and 16 in?
False. True.
Remember, the same inputs need to map to the same outputs. So here's what you can do to check it quickly. Just hit the up arrow on your directional pad until the equation is highlighted. So you'll have to hit it twice until the equation is highlighted. Hit enter. It's going to bring that equation down. And then what do we need to put in the place of this 9 here? We need to put
4, -4.
16.
Remember, this is my y, right? So this is 16. What's going to take the place of this x? Type that in. What does it tell us? Does it tell us true again? Oh, look at that. If I did this with every single point on this function, what is that equation going to tell us? True. The whole point is that all of these inputs and outputs go with this equation. That's how this is equivalent, because the inputs map to the outputs, right? If I were to just put in a -4 here, what I would get out is 16. If I put in a -1 for x, what am I going to get out? 27/4, right? Guys, these things are important to understand. And so, I think it's fair to say, Sanaya, did we ever study that in Algebra 1? Did you ever study that in Algebra 1, looking at those inputs and outputs like that? You did? Okay. So we should know this. If we didn't, we need to learn this, because this is foundational. This is not even Algebra 2, this is just foundational for being successful at Algebra 2. So, we've already talked about number 1. I want us to try to finish up number 1, doing our sorting within the next 15 minutes. That doesn't mean we have to have it perfect, but we need to sort our function, or our relations, into what type of groups? They need to be what? Equivalent. So they need, the same inputs need to map to the same outputs. Yes, Jamarcus.
I got a question before we start.
Go for it.
Alright, you probably like explained like a whole bunch of times, but how you get -3/4 again?
You mean this times 3/4?
Yeah.
Okay, so there's two ways. The one that Lily Kate did is the easiest. Lily Kate just took that 12 and you divide it by the previous value of 16. Okay? You could also just take in the 9 and divide it by the previous value of 12. So if you just take a number and divide it by the previous, if it's exponential, it'll give you a constant factor. You can also see it right here, and this is, if you're not comfortable or don't remember this, what would I need to multiply 9 by to get 27? 9 times what gives me 27? See that 3 right there? And then to get it divided by 4, 9 is understood to be divided by 1. So what would I need to divide by to get divided by 4?
4.
Right. So you can see it when we have those fractions really easily, that I'm literally just multiplying 9 by 3 and dividing by 4 at the same time. Does that make sense? And that's another reason why I don't want y'all to just say over 4. You're robbing the mathematics of what it means if you just say over 4 instead of divided by 4. Okay, and that does matter there. But Lily Kate did remember that easiest path of just dividing those two numbers. That'll always work if it's exponential. So that's why we need to look at it. And so that's why Lily Kate checked multiple. All right. Let's get back to sorting within our groups. Hayden, talk with your group, see what they've already sorted. We're going to take 15 minutes. Now you should get that head up. We got stuff to learn today. We got some sorting to do. Yes, ma'am. Ask a question, okay? So, hey, listen, we're going to start talking about these some. If you are uncomfortable with an idea, I need you to ask a question. Don't forget, literally, your daily score, which I haven't put in the last 2 weeks, sorry, I've been really behind, but your daily score is partially built out of you doing what?
Work.
Not just work, or actively collaborating, talking, and what's one of the ways to talk during whole class discussion? Ask questions. Like, we say that my class is stressful, or some of us think my class is stressful, and I get that, hey guys, I get that my class is stressful because I'm asking you to understand, but I literally have never gotten upset with someone asking a genuine question to understand. Now, if it's because you didn't pay attention, I might get a little frustrated, but I will never be upset because you're trying to learn and grow. Ask all the questions. That's how I learned as much as I have. So, here's what we're going to do. Can someone just start us off? And I think group 4 got through this pretty quickly. So, Lily Kate, Sanaya, or Grace, how did y'all start to group your set of relations?
We started at the grass.
Okay. Hey guys. Hey, we need to participate in the whole class discussion. Small group discussions are done. We need to pay attention. We also need to take notes. By the way, we went over both understanding checks last week, and literally like half of us took 0 notes or took ineffective notes. You gotta write down notes to explain why. If you cannot explain why, you don't fully understand. So I need us to take notes about why. Now this is just a start to it, but you looked at the graphs first?
Yep.
Okay, why did you look at the graphs?
So we could get the points and to see what.
Okay, so graphs, that gave us points. And where did you look for those points? On what?
On where they indicate. Hold on, give me a second.
You're good. While Sanaya is looking for that, does anyone know where a good place to look for those points might be? What representation? Well, they looked at the graphs first to find points, which we can find points easily where? Tables, right? I'm not saying that's what they did, but if I was looking at my graph first to identify points, I'm going to go then look at the table. That's an easy check to say, these points line up, right? Because inputs need to map to the same outputs, okay? Naisha?
If you put the equations in the calculator, you can find the graphs.
Oh, could we have just graphed those equations on our calculators? Yeah, that might have made things easy. We're going to come back to that at times. Now, I need you to hear me clearly on this, though. Listen. Did anyone... Okay, let me ask this before I say anything else. Did anyone do anything else to get started? No? Okay, let me ask you this. Did no one just say, hey, what type of function is this to get started?
No.
Yes.
Because if I'm looking at y equals 2x, not 2 to the x, just 2x, what should I know about that immediately? It's linear. So I'm only going to look at what type of graph? A linear graph, a line. And I'm only going to look at what kind of table it needs what rate of change? Not just additive, constant additive. Miracle, you with us? Good morning. Good morning, Miracle. Forgot to say that earlier. And? There you go. So, please understand, right? We need to recognize that we start with the type of function. We skip over that detail. We almost made this harder than it had to be. If I was you, the first thing I would do is I would identify the type of function. Because how many linear functions were there? There was one. How many exponential functions were there? I'm pretty sure there's only one exponential function. So we need to look at that. There were quite a few quadratic functions and one relation that was not a function. But I would have looked for those kinds of details. Look for what they have in common. So if I were you, under number 1, I would say I tried to group the same types of functions together first. Or you should group the same type of functions. Like I would have just put, even if there was more than one, I would have put all my linear functions together. I would have put all my exponential functions together, and I would have put all my quadratic functions together. Yes, Rakai? Yes, you look on the bookshelf back there on the left, on the top shelf. Guys, start at the basics. Instead of just having to go into the nitty-gritty inputs and outputs, a linear function, a linear equation is not going to be a quadratic graph, is it? No. A linear equation will never give me a parabola. So I wouldn't even look at those. Identify the types of functions first. So number 1, Cam, did you write this down? Number 1, group the types of functions together first. Right? Under number 1, group the common types of functions first. Then figure out which ones are equivalent. We made that way harder than that had to be. For number 1, group number 1, group the common types of functions first. I guess I really should say relations there because it's one relation that was not a function. But again, a linear equation is never going to give me a parabola. If I see in a table that it's constant multiplicative rate of change, is that going to give me a parabola? So if I can identify the constant multiplicative rate of change, I know it's exponential. So, hey guys, please pay attention to this. This means we need to know, hey guys, this is why we did that understanding check last Wednesday. You have to know what type of graph is a quadratic, what type of graph is exponential, and what type of graph is linear. You have to know what type of rate of change is exponential, what type of rate of change is linear, what type of rate of change is quadratic. You have to know quadratic, linear, and exponential equations. You've got to know those things that separate them. Otherwise, all of this becomes way harder. You've got to know those things. Now, it is important. We already addressed number 2. At the end of the day, what should you use to sort the representations into groups? First off, start with common types of functions, right? What other strategies do we use? I heard one group say that, so that can go under number 2 as well, but I also heard use a calculator to graph equations. Can you do that? Can you use a calculator to just graph equations? Now, hear me clearly on this. Every test I do, not understanding checks necessarily, but every test, I have a non-calculator and a calculator portion. So, when it comes to equations, if I'm asking you to identify the type of function off an equation, that would be a non-calculator portion. You need to know what makes those different equations the way they are. Because I want you to think, and not just plug something into a calculator. But for now, we can use graphs to, calculators to graph equations. Is this a strategy? Use a graph to identify points that go to a table? Yeah? So, use graphs to ID points and find points on a table. How could we, yes ma'am?
What does that say after graph in the first one?
Oh, EQNS is an abbreviation for equations. EQNS. EQN is an abbreviation for equations, so putting in S makes it equations. Good question, sorry. That's a, depending on the teacher or the mathematician, it's a common abbreviation. I totally forgot about that. But use graphs to ID points and find points on a table. Can you use that to identify the equation as well? How would we use that to find the equation looking at those points? So you could look at the y-intercept and the rate of change, and now we need to write the equation, but there's actually an easier way. If I have points, what do those points need to do to the equation? Guys, we did this. Those points need to make the equation what? Say it louder. True, right? So use graphs to ID points and find points, or find the points on a table, and those points make the correct equation. True. That's the whole point, is that those points make the equation true. Okay, I'm going to come back to number 3
That's the amount.
later. Huh?
What does it say?
Where? That's underlined?
On that table. Point.
And.
Oh.
That's not much better. These are strategies that you need to have always ready to be able to learn later mathematics. These are strategies that you always need to have ready to learn later mathematics. By the way, Cam, this is on the next page, number 2. You don't have to do it, but that's number 2 on the next page. It's fine. I would just make a note to yourself that that could go under number 2 and not rewrite it. So at this point, let's start looking at our groupings. Okay, we're going to write these groupings down under number 4. So I'm going to skip number 3. Don't let me forget to come back to number 3. We're going to go to number 4 though and write these groupings down. So here is relation A. The way that I have built these slides is that I start with the first relation alphabetically. So relation A. Alphabetically, so looking through your groups, alphabetically, what is the next relation that goes with A, that is equivalent to A? J. Did anybody get a relation before J? I had F. Mm-hmm. Mm-hmm.
Oh, yeah.
Okay, so here's what I will point out. Let's pause and let's look at it. So I 100% understand why we missed F. Let's look here. Oh, I also had I, and there's J. Okay, so we had something before J. So I wanted to point this out. Was there any way that we were going to know F and I off the top of our heads?
No.
Oh, I did.
How'd you know?
I just looked at them. They look the same.
Okay. Okay. So this is going to get into, please hear me clearly on this. Okay, there is one more card that I believe goes here, but we'll talk about that in a second. What I want to point out is this. This one, what type of function is this?
Quadratic.
Quadratic function. How do we know that, Jamarcus?
It's concave down.
It's a concave down
Parabola.
parabola. Okay, so hear me clearly because I saw this on the understanding check. The concave down is not what makes it a quadratic. The parabola is what tells us it's quadratic. Concave down is the direction of that parabola. Okay, so learn from that. The parabola is what tells us it's quadratic. Its concave down is just the direction. Okay, so yeah, man, I could have put inputs in to get outputs out. But I will say, have we done a lot with these types of functions? No. So what could we have done pretty easily? Well, one, we know it's not linear. What else do we know? It's not exponential. But I'm saying, how could I have easily figured out that this equation and this equation go with this graph?
Calculate.
Pick up your calculators, guys. What kind of page am I going to create on the calculator? I'm going to go to a graph page. Traylon, are you with us?
No.
Come on, pick up the head up. Okay. So we got a graphs page. what would I type in under f1 of x?
No more.
Either equations, right? So I'm going to start with, I believe it's negative parentheses x plus 3 parentheses x plus 3. So type that equation in.
Mr. Kenny,
Yeah.
you don't gotta take the one off.
Hmm?
You don't have to take the one off.
That 1 just tells us that it's the first function. The second function will have f2. You typically would not write that on doing it by hand, but you'll actually see it in the book for one lesson as well. So I'm going to hit enter. Now I need to graph the second equation,
When are you done?
right? How am I going to graph that second equation? Yes, ma'am. Did I put F already in? Or that's equation I. How are you getting 2 and 2.5? Oh. So go to actions, delete all. But that's also why you don't necessarily always want to use a scratch pad. If you just go to home and create a new document, then you won't run into this issue. There you go. So guys, remember, if you want a new function, you have to hit what first? Menu. Hit menu for me. After menu, what do I want? 3, graph entry / edit. And so, can I use function in this case? Yes. Notice, Eliza, how I did f2 of x? That's how it's indicating that I have the second function in there. Because you're asking about deleting that f1, or the 1. So now I'm going to type in, was it negative parentheses x squared plus 6x plus 9? Right, so that should be the second equation we have typed in. Remember, you don't have to look at the board. It's relation F on the cards. So we should have relation F in the cards.
Oh my God.
So first off, I want you to look at the graph. How do we know that these two different equations are equivalent functions?
They're on top of each other.
Do you know what the mathematical word for they're on top of each other is?
Overlap.
That might make sense, but think about the terms that we've actually talked about with relations. We would say they map to each other. Every input maps to the same output, right? And so that's how we know they're equivalent. I'll also point out, is this the same as the graph that we saw? Is that the same as the graph that we saw? These are just two different forms. This is known as a factored form of a quadratic. This is known as the standard form. We may not get to it today, but when we get to Desmos, that's what we're going to be focusing on, is those different forms of quadratics. Okay, so we're going to learn about those more. Yes, Lily? Yep, be quick. So, really quickly, I do want to show you this. Okay? It's not random. You actually already know how to go from that factored form to the standard form. Does anyone know what I could do algebraically to go from this factored form to the standard?
What side is right?
If I just do x times x, I get x squared, and 3 times 3 gives me plus 9. I'm missing the 6x.
How you just?
I know, how do we get that 6x? Let me ask you this, if I had just x times x plus 3, what would you do? So you would distribute, right? So do you know what I'm about to do here? I'm going to distribute. What is x times x? X squared? Jaylee, what's, okay. What's x times 3? So 3x. Now I distribute this 3. What's 3 times x? And 3 times 3? What like terms do we have? That's how we get our 6x and I. Does that make sense? Okay? Hold on a second. Correct. Yep. And we'll study more about that later. But I do want to point this out, right? There is an algebraic reason to show that these are equivalent. There's an algebraic reason to show they're equivalent. But could I have just seen it on the graph that they map to each other? Yes. We have graphing calculators. Please understand, math is the study of what again?
Relationships and patterns.
Patterns and relationships, okay? And so we are just now looking at these patterns and relationships with quadratics, so don't stress it, but we want to be aware and start to look at these things, okay? Does anyone need to ask a question then why these four relations all go together?
No.
Last one.
Wait.
Look at the points.
I said it.
Negative 3 zeros right here. Negative 4. No. Negative 4, negative 1 is right here. Negative 2, negative 1. Negative 1, negative 4. And 0, negative 9. All 5 of those points match that table, don't they?
Yep.
And guess what? If I put those points into the equation, they're going to make that equation what? True. So under number 4, we should write out A, F, I, J, M.
No way.
F, I, J, M.
It's not cool.
Okay? A, I, F, J, M under number 4, Cam. So, I do want to point this out because I know, right, tonight the way I teach is different, right? Here's what I want y'all to understand about the way I teach so that you can be successful. Math is the study of patterns and relationships. I may not do it perfectly, but I'm trying to make sure we all have the foundational information. Hey, group 6, we're going to have to find new groups starting tomorrow so that we can focus better. So tomorrow, just be aware, you start where your group is right now, but I'm going to randomly generate new teams at the beginning, after we do the bell ringer. But I want to point this out, okay, so we're going to randomly generate. I actually found out recently that educationally it's better for students if I randomly generate every day. I might do every 2 days, we'll see.
That's doing it.
Huh?
That's doing it.
Yep, it is. It's doing what I have learned based on research is best for students. Okay.
We good, bro.
What I want you to understand is this. Math is the study of patterns and relationships. Thank you, Naisha. You can engage in this activity to explore, but am I just going to abandon you and say, okay, you've got it now? Like you figured it out in your small groups, moving on. No, every time after you do small group activity, we have a whole class discussion. This is the direct instruction that you are used to having. You're used to having it at the beginning. I'm going to ask you to work most of the time, and then we're going to have it at the end to build up your understandings. So, alphabetically, the next equation was function was B. Oh, by the way, in number 4, next to those relations, what type of function were we looking at with A, F, I, J, and M? Quadratic. I was right next to the book because in number 4 it does tell you which function family. We're looking at a quadratic there, right? So A, I, F, J, and M was quadratic. But now I do want you to look for relation M, B. Why did I say M? You can't hold 13 minutes? So, alphabetically, what's the next relation that goes with B?
E.
E? Okay, someone said Q, but I have E as well. How? Huh? Alphabetically, the next one was E. How do we know that these would go together? How can we show that?
5 is the y-intercept.
So one thing is that 5 is my y-intercept. That's good. Now, that's not everything, but I'm just asking, what's the easiest way to know that every input and output here matches with this equation? What could I have done? What with the calculator? Yeah, I could have graphed that. I could have taken this point. Notice negative 1, 4 should make this equation what? This vertex right here, negative 1, 4, should make this equation true. So I can do that as well. Okay, alphabetically, what's the next relation? W. I heard someone say Q. Do we have Q here? No? Ooh, I had one more. Did you say L? I missed you saying that. Remember what group 4 said. Didn't they say that they took the points from the graph and looked for that table? What's this point? Right here, the vertex. Negative 1 comma 4. 0, 5. 1, is that 8?
Yeah.
Does that match the table?
Yeah.
Yeah? If I check the left-hand side, will it also match? So guys, notice, we can pull points off the graph to see if they make the correct table. In the same way, could I have taken this table and graphed the points? So I could go back and forth either way?
Yeah.
Focused on the whole class discussion. Are we or should we be? I think we're not, but we should be, right? Let's focus, okay. Was there any more that were equivalent in this case? W maybe?
Oh, no, it ain't W.
Two.
Oh, because W was a table? So it can't be W? That was all I had. I only had those three. Unless I made a mistake.
Bill.
Okay. So we should have B, E, and L together. And we should identify it as what type of function? Quadratic. I do want to point this out. If you look at the equation, what in the equation tells us it's quadratic? Let's say again. Second degree. The highest exponent is a 2, right? Second degree. In a graph, what do we see? A what? Parabola. What should I see in this table? What kind? Because remember, and this is why I have to be careful, linear functions have constant addition. Quadratic functions have not just addition. What type of addition? Linear addition. To go from 8 to 5, what's happening? Not just 3. Subtracting 3, then notice is that constant. But to go from negative 3 to negative 1 is adding 2, adding 2, adding 2. That's constant additive. What is always to the left of a constant additive? Starts with an L. Linear. Well, just in general, linear, right? Linear is always to the left. And notice this is addition and subtraction. It's a rate of change, so it's linear additive rate of change. Because it's linear additive rate of change, this is the function, the y's.
Oh, wow.
Remember, it's a linear additive rate of change, so the function is quadratic. Remember that linear additive rate of changes was defining a quadratic. We've got to notice those things. They should all tell the same story from a different perspective. That's part of the beauty of mathematics. I know that we're not used to looking at math that way. We're used to being told, hey, here's this equation, graph this function, things like that, but there's beauty and flexibility, and I want you to see that. So the next function, or relation not algebraically, next relation alphabetically was C. What was the next alphabetically that went with C? G. Did anybody have something before G?
K.
K is after G,
Yeah.
right? Hey, there's G.
And then K.
And then K?
Or S, yeah, S.
Oh,
Just, I mean,
I did not have K.
you and
And then S, yeah.
Okay.
And then U.
What was K? I did not have it here.
CGK.
Ah, K. Look at K again. Louise heard a rumor. She tells the rumor to 2 people the next day. So originally 1 person knew, right?
Yeah.
And then the next day, how many more people learned about it? 2. And then each of those 2 people told 2 more people, so there are 4. So notice day 1, or day 0 there was 1, day 1 there was 2, day 2 there was 4, but what's happening in K after that? It's multiplying by 2. What's happening here? Repeated addition by 2. Now remember in the equation, guys, listen to me clearly on this. The repeated addition by 2 is shown how in the equation? How do we show repeated addition by 2 in the equation? What about that 2x? We're missing a key detail. What shows repeated addition? What operation shows repeated addition? Multiplication. Remember, that's what makes this function what type of function? Linear. That multiplication is showing repeated addition, making it linear. The multiplication here is showing repeated addition. What are your questions about these going together? Any confusion there? Notice all four of these relations were what type of function? Linear. How do we know it's linear in the graph?
It's just
What?
a line.
It's a line. Literally a graph is a line. Please notice how I say that clearly every time. The graph is a line. Have you ever heard me say it's a line? No. We need to be more clear with our language. The graph is a line. Did I call it a straight line? No. Is it a straight line?
Yes.
Yes. But for it to be a line, it has to be straight. It has to have that slope. So you can just call it a line. Alright? But notice constant additive rate of change by 2. So we should have CGSU all together in under number 4. And the type of function is linear. CGSU. And if I were y'all, I would make sure I'm grouping mine like this. I would hold on to my cards. I might put them right here in the book so that I can use them to study and look back over and remind myself of these details. You can only study as well as you have strong notes. Alright, next one alphabetically was D. What went with D? Next one alphabetically. What was it?
H.
H. Did anyone have anything before H? Did anybody else have H?
E.
You had what one? E?
Oh, never mind.
Okay, well, I thought we already did E.
No.
H. I got H as well. I want you to notice. Again, this goes back to the factored and standard form. What would I do to go from this factored form to this standard? I would distribute. What's x times x? Remember, to show repeated multiplication, I need an exponent. Right? Those are being multiplied. X times 1? 1x. 5 times x? And 5 times 1? Would I simplify? Would those be equivalent? X squared? What's x plus 5x? Plus 5? So we can see it there. We also could have done what with those two equations? We could have, starts with a G, graphed them, right? Alright, alphabetically, what's the next one?
P.
Alright, P as well. This is the last of the forms called a vertex form. Okay, we'll study that in Desmos. And any other relations that went with this?
T.
What was it? T? I had T as well. I will point this out. You see that vertex form? This point right here is -3, -4. When we look at that vertex form, you see how there's a 3 and a 4 there? We have to figure out how it's kind of working, but they go together somehow. Okay. Was that the last relation for this group? Okay. So we need D, H, P, and T. And we would say that they are what type of function? Quadratic. D, H, P, and T. And those are quadratic. Oh, W. I had W as there as well. That's where W fit. And if you check the points, they will map over here, right? -5, 0, -4, -3, 0, 5. I can't see the rest of those. But you see how those 3 points map to that table? Right? So W went there as well. So Louise heard a rumor. She tells the rumor to 2 people the next day. Right away, we were talking about this already. What's repeatedly happening is being multiplied. So this is what type of function? Exponential. We have N, Q, R. Those are the exponential functions that go together. Do I need to address Y with that one at all?
No.
So that means X, O, B together.
So K, N, Q, and R go together under exponential. Uh-oh, I missed the relations one. The circle, which one was, that was O, V, and X. Now, I do want to talk about this equation. Was anyone tempted to call this a quadratic? No? Because the x squared made me kind of think quadratic. Hey guys, listen, okay? What could we have done to figure out what this equation looks like though? Graph it. Please note, is it y equals or f of x equals? No, so could I graph it under function? No, I had to graph it under relation. If you graph it under relation, it gives you that circle. But what we would want to write here for those three is that it's a relation, it's just a circle. Okay? Number 3, really quickly, how do you know which relations are functions and which ones are not functions? What do you need to talk about there? To be a function, each input maps to, not just outputs, to be a function, one and only one output. Make sure under number 3 you make that note, each input maps to one and only one output to be a function. Each input maps to one and only one output. I know at times there's a struggle, but I think there's been some good learning today. But what are all of you? Capable of more. We got to keep growing and learning.
Miss Kenny, you gonna give us one more chance?
For what? No, we need it. Legitimately, the research shows I need to change up seats.
Yeah, the research.
So, no more homework. I still have grading to do. Bring your iPad with you tomorrow. It needs to be charged. You need a charged iPad. Borrow a charger from a friend and during enrichment if you need to.
This film.
Okay.